Welcome, my dear students, back. We will talk now about the fourth criterion of the criteria which is used for decision making in the uncertainty situation, that is called the expected value. And we will have two lectures about this. The first one is right now, and the second one is using the expected value when we decide to draw the decision tree. So we can do it by either what I will do now on the table itself, or I can draw the decision tree, and both are the same. Let me show you something. Till we come to the decision tree, let me show you what I mean by this. This is the expected value. You will set probability, summation of probability divided by the D. The each expected return from every alternate. So it will appear, because it might looks like very complicated, but it's very easy. I will show it to you just now. You will set a probability distribution for the three states of nature. You have a state of nature 1, state of nature 2, state of nature 3. And you will put the probability distribution for them as example. This is done by the management, not us. So the management will put a probability as example. In the states 1, there is a probability to get $10,000 as example, 60% to have return or earnings of $10,000, and 20% is 2.2 to have $6,500, and 20% to have minus $4,000 in the states of nature 3. So we put a probability distribution. The only thing, I can get it from the table just now. I will calculate it from the table. But either there is another solution when I use to draw the tree. It's the same thing. All I did is just took the table out and draw the tree. That's it. I draw the tree. So I have here as example for the alternate one, $10,000, 6.6. Here is the 10,000, and here is the 0.6. And I have 6,500, this one, with 0.2. This is a 0.2. And I have 4 minus 4,000, with the probability 0.2 as well. Likewise, I did for the first one, I will do for the second, and I will do for the third. So I can do it either by the expected value, which is from the table directly, or I might give you a tree ready-made like this, and you calculate. And whatever you will calculate from the decision tree is same like when you calculate it from the table exactly. Let us go for the probability distribution of this example and put it on the board and see what we will get. Let us see how it works. Now, I'm not talking about minimum of the minimum or maximum. I am in the criterion which is called expected value. I'm in the criterion which is called expected value. That's fine. How I will do the expected value? Expected value means the profits in the probability, like, or the returns of each alternate, the returns in the probability. So the probability expected value, EV, will be summation of probability in, you can say, in the return, in the times return. Probability times the returns, which we have here. So as example, but he gave me, wait a minute, he gave, the management said that S1 is 60%. Let me do it in another color, okay, so that it will be appear. This is 60%. Hopefully, oh, yes, we didn't share. We stop share here. Wait a minute. We have to stop share and I have to repeat this back. Okay, okay. I was just copying what's in the paper here on the board. So here, the probability is 60% for S1, and the probability, let me get a blue pen, blue big pen, okay, So here is the probability 60%, 60% for S1, 20% for S2, and 20% for S3. With a black pen, here it is 60% for S1, 20% for S2, and 20% for S3. I hope that is clear now. Okay. Okay. So how I will calculate? I will say the expected value for D1. Expected value for D1, expected value EV for D1, EV for D1 will equals $10,000 0.60%. $10,000 times 60%. Okay, I want to tell you something. 60% is 0.6. It's the same. So it will be 10,000 times 0.6 plus 6,500 times 0.2. 6,500 times 0.2. And I will close the bracket. Plus minus 4,000 times 0.2. 4,000 times 0.2. Here 6,500 times 0.2. Here is 10,000 times 6. You will multiply the revenue and the probability. That's it. Each revenue and its own probability. Then the first number will be, like I see here, when it's calculated and when it is done, it will be $6,500. It will be equals $6,500. Okay, this will comes to 6,000. When we finish calculation, it will be $6,500. Okay, that means here is the first alternate will be $6,500. Okay. I want you to do the second one and the third one. Again, let me do it in other color because it does not appear. I want the probability to be with another color. So it will be shown up to my dear students. This is 60% or 0.6. This is 0.6. And this is 0.2. And this is 0.2. All you will do now is again the calculation. You will do for the second row. Okay, here is the second row. Here is our second row. The same thing. For the second row will be 8,000 times 0.6. Here the expected value for D2. Expected value for D2 will equals $8,000 0.6. $8,000 times 0.6 plus 6,000 here, $8,000 0.6 plus $6,000 times 0.2 plus $1,000 times 0.2 as well. 1,000 times 0.2. This will equals, this solution will equal, we'll check out here. Now we'll see the number. It is $6,200. When you do it with your calculator, it will be $6,200. $6,200. So this is the second number, $6,200. $6,200. Okay. we still have only one. And I think it's from its own self, like when you see here, let us see how much it will be, but it will be 5,000 because all of them is 100%, it will be 5,000. Let us see. Third D, how I will get the expected value? The expected EV means expected value. So it's the probability by the return of each one, the numbers here in the cells, times or multiplied by the probability. The probability we have four up here in green. Okay. Third row, then we'll see EV for D3, EV for D3 will equals 5,000.6. 5,000 times 0.6 plus 5,000 times 0.2. 5,000 times 0.2 plus 5,000 times 0.2. 5,000 times 0.2. This will equal 5,000, of course, but just make me double check. Yeah, will equals 5,000. Will equals 5,000. We come now to the decision points. The decision point where I am. Which one I will choose based on the expected value criterion. Based on the expected value, which one I will choose? 6,500 or 6,200 or 5,000? Based on the expected value, based on expected value, choose the max. Choose the max. Based on the expected value, choose the max. Choose the max. So, what is the max here? The max is 6,500. So here I will highlight it, 6,500. Then based on this, D1 will be the solution. 6,500 is the highest or the maximum, is the max EV. Max EV means maximum expected value. And this method, like we said, is called expected value. Expected value. Don't forget, we multiply the probabilities, which is in green here, in the revenues of each decision or alternate D1, D2, D3, like the way I showed you. Then you will choose the highest number. So you will multiply by the probabilities. Then the second step is that you will choose the maximum of the column which you made, this column which you made. You will choose the maximum of it. Thank you so much and have a good night. See you. Take care of yourself. Bye-bye, everyone.